Hey everyone, welcome. Get ready for a cosmic field trip today. We're going to be exploring the absolute most fascinating objects in our universe as we go through this explainer of the Shadows of the Cosmos primer. So, buckle up, make sure your astronaut helmets are on tight, because we are heading way out into the deep, dark cosmos to look at something truly mind-bending.
Okay, let's just dive right into this by asking a really big question to kick off our journey.
What do you think is the single most misunderstood, mysterious object out there in the dark? Is it like a rogue wandering planet, a glowing comet zooming past? Or maybe is it something so powerful and so secretive that we literally can't even see it with our own eyes? Here's our quick lesson plan for today. We're going to meet the black hole, see how they form, talk about their anatomy, including something crazy called spaghettification, look at the different types and supermassive giants, figure out how we spot the invisible, and finally wrap up with why black holes actually matter. All right, first stop on our trip, let's officially meet the black hole. What exactly is it?
So, the first thing to know is that a black hole isn't actually a solid physical object you can touch, right? It's not like a rock or a planet. It's really a region in space where gravity pulls so intensely that absolutely nothing, not even light, can escape its grasp. Imagine the strongest magnet you've ever played with in science class, but instead of just pulling metal, it pulls literally everything, even the light shining from a flashlight. And because no light can bounce off of it to reach our eyes, this region appears completely, perfectly dark to us. Moving right along, let's look at how these things actually form. The birth of a cosmic giant.
This whole sequence shows the incredibly dramatic life cycle of a star. It proves that black holes are essentially the leftovers of huge dying stars. So, step one, a massive star, and we're talking one much, much bigger than our own sun, finally runs out of the glowing fuel that keeps it shining so brightly. Then, step two, without that fiery energy pushing outward to balance everything out, the star's heavy core just completely collapses under its own extreme gravity. All that material rushes inward in this massive, unimaginable crush. And finally, step three, out of that unbelievable collapse, a black hole is born. It's kind of like nature's ultimate extreme recycling program, if you think about it.
Okay, next up is anatomy and spaghettification. What happens when you get just a little too close?
So you gotta think of the event horizon as an invisible, almost magical border out in space. It's the absolute point of no return. It's a lot like the perilous edge of a cosmic waterfall where everything just falls in. Think about it like this. If you're paddling a little boat in a river right above a regular waterfall here on Earth, you can still row away if you're far enough back, right? But once your boat crosses that very edge, the event horizon, the current of gravity is simply way too strong to fight against. You are going over. And if you did fall in, well, you would experience spaghettification. Yes, that is a real science word, I promise. It basically means the extreme stretching of an object by a black hole's gravity, pulling it out like a long noodle or, a giant piece of bubble gum. Because the gravity of the black hole would be pulling so much stronger at your feet than at your head, you'd literally be stretched out. It's definitely as funny to say as it is wild to imagine. But don't worry, we are keeping our little field trip spaceship at a very, very safe distance today. Now let's talk about the types and the supermassive giants, sizing them up. It turns out black holes actually come in completely different weight classes. First, we have stellar black holes. These are the smaller ones, formed from single collapsed stars, exactly like the ones we were just talking about. But then, we have supermassive black holes. These absolute monsters are millions or sometimes even billions of times larger, and they sit right at the very center of galaxies, including our own Milky Way galaxy. They're basically the heavyweights holding the whole thing together. Which brings us to spotting the invisible. How do scientists actually detect them? To find them, we kind of have to act like space detectives. We obviously can't see the black hole itself, but we can look for the clues it leaves behind. First, we do this by watching how nearby stars orbit around a seemingly empty, invisible point. Imagine seeing a group of people holding hands, dancing in a tight circle around someone you can't see. You'd immediately know an invisible partner was right there in the middle. Second, we can detect them by spotting powerful X-rays coming from super hot matter swirling into the black hole. As space dust gets really close, it heats up and glows so brightly before finally falling over that waterfall edge. All right, time to bust a really common myth. A lot of folks think that black holes are giant, hungry space vacuums just roaming around sucking everything up like some kind of monster looking for a snack. But the actual fact is so much cooler. They have completely normal gravity, it is just packed extremely tightly. Listen to this. If we magically replaced our sun with a black hole of the exact same weight, the Earth wouldn't get sucked in at all. No way.
We would just keep orbiting normally, just in the dark.
And finally, why black holes matter. Let's look at the big picture.
Black holes are basically the ultimate laboratories of the universe. They help us understand gravity, time, and how entire galaxies are actually shaped. Now, I know they might seem a little scary or strange at first glance, but they are absolutely crucial puzzle pieces that help us understand how our beautiful, vast universe works. Honestly, without them, galaxies like our own Milky Way might not even exist the way they do. They test the very limits of our science and push us to learn more every single day.
I really hope this explainer sparked your curiosity today and leaves us all wondering, what else is hiding out there in the dark corners of our universe, just waiting for curious minds like yours to find it? Keep asking questions, keep being space detectives, and absolutely keep looking up, everyone.